In this unit, we'll be looking at angles and parallel lines. This lesson is about the pairs of supplementary angles formed by parallel lines in a transversal.
Okay, hi everybody. In this video here, we're going to take a look at a second set of angle relationships that are formed by the transversal and parallel lines. So in this case right here, we're going to look at straight line angles. Okay, and these are going to be related to our supplementary angles that we would have looked at in a previous video here. So there are two or more angles that form together to form a straight line. When you put them together here, you add them, for example, A and B, you put them together, you get this straight line, this 180 degree angle there. Okay, same thing with these two. You put this angle together with this one, you get a straight line 180 degrees. These two angles are supplementary. Okay, the result, straight angle. Now this is significant because remember from a previous lesson here we were looking at transversals, a transversal across parallel lines. And again, I'll put little markings there to show that those are parallel. Okay, so what we're trying to do here is we're trying to look at the relationships that we're seeing here between the measures of the angles in this particular lesson. So from the 8 angles in our previous diagram, the following pairs would be straight lines. They would be supplementary. Okay, in other words, these pairs of angles are going to add up to 180. And by the way, there's a bunch of them here. Okay, we're only going to take a look at a group of them, but you should be able to see pretty quickly from this that there's going to be a bunch of others. So for example, angles 1 and 3, when you put those together, okay, they form a straight angle here because they're together, they're riding along the transversal. So angle 1, angle 3, add them together, we get 180. They're supplementary. Okay, angles 2 and 4, because they're on the other side of that transversal, and they're doing the exact same thing. Now another way to look at it is now let's take our attention off of the transversal. Now let's look along the parallel line here, one of the lines here that are parallel. Angle 1 and angle 2 both add up to 180 degrees. They are supplementary. And if they are, so are 3 and 4. And by that argument, by the way, we can find sets of supplementary angles down amongst angles 5, 6, 7, and 8 as well. Okay, so I hope you see the connection there. So that's one relationship between the measures of the angles. Another relationship between the measures of the angles are what we call same-side interior angles, okay, or consecutive interior. So same-side interior, again, same side means that they're on the same side of the transversal. In a previous lesson, we looked at alternate interior angles. They were on either side of the transversal. So now we're on the same side of the transversal. And they're interior, which means that they are between the two parallel lines. And so you get this little C sort of a shape here. Now, it turns out, okay, that these particular angles are complementary. Okay? They add up to, I'm sorry, I can't believe I just said that. They're not complementary. I'm sorry. I knew the last one was supplementary, and for some reason I just immediately wanted to write down these ones are complementary. I think it's because of the C there, quite honestly. These are also supplementary. They are also going to add up to 180 degrees. This angle plus this angle adds up to 180. Now, if that's not immediately obvious, I just want you to think about it like this. Because of a previous rule, I know that this angle right here will be the same as this angle, okay, because these two angles are corresponding. So ignore this one right now. If these two add up to 180, then those two must add up to 180. And that's the same sort of argument here. These two angles here would add up to 180. Now, from our diagram with the 8 angles here, our same side interior angles, there's only a couple pairs here, would be angles 3 and 5, and those two angles would add up to 180, and so would angles 4 and 6. Okay? So just to give you some ideas of some of these other relationships that exist there. Now, before we do some examples here, just really quickly want to talk about perpendicular lines. Okay? And we use this symbol for perpendicular lines there. These are lines that meet at 90 degrees. Don't get them confused with just intersecting lines. Okay? When lines intersect, they don't necessarily have to intersect at 90 degrees. They can, and if they do, they're perpendicular. Okay, and we put a little mark there to show that they're perpendicular. But the way lines can intersect on a plane here is they can just be intersecting lines. Okay, they can be perpendicular lines, or they can be drawn without intersection. And again, remember, lines are infinite. Okay, so they go on forever here. And so parallel lines in this case would not intersect with each other at all. And we're going to talk about parallel lines a little bit later. Anyway, let's take a look at some examples now. Okay, so now in this question here, it says consider the diagram on the right. And again, it doesn't specifically say that those are parallel, so let's make those little lines there so that we know that they're supposed to be parallel. And then for each of the following angles here, or pairs of angles, we're going to name the relationship. So angles 7 and 8. Okay, 7 and 8. Now notice that both of them are on the same side of the transversal, and they're both in between the two parallel lines. So these are what we call same side interior, or consecutive interior. When I was doing this course as a student, we called them same side interiors. That's kind of what my default is on this one. 4 and 7. Okay, 4 and 7 here, those are going to be supplementary angles to each other, right? They're going to add up. So we're going to call those straight line angles. Oops. Straight line angles. Because they add up again. They're supplementary. They're going to add up to a straight line. 6 and 8. Okay, 6 and 8. Now, we're kind of opening this up to stuff that we've done in a previous lesson. Notice the point of intersection. Notice that in both cases the angle is above and to the left. Above and to the left. And we call those corresponding. Angle 6 and 4. Okay, 6 and 4. Now, that's usually an easy one to recognize here because the X that's formed, they're on either side of the little X formed by the intersecting lines. These are vertically opposite. And remember, vertically because of the vertex. Angles 8 and 3. Oh, okay, angles 8 and 3, either side of the transversal, but okay, together forming a straight line. So basically, there's another pair of straight line angles. And then angles 4 and 3. Now notice they're on the same side of the transversal, but they're both in between the parallel lines. So these are same side interior. So the names really just tell you where they're located. So as soon as you sort of get used to the names, really it's pretty straightforward to see the angles and the angle relationships in the diagram there. So now which angle is straight or supplementary with angle 6? Okay, well where's angle 6 here? Okay, so here's angle 6. So which angle is straight with that or forms a straight line? Well, it could be angle 7. If the straight line that we're talking about is the transversal. If the straight line that we're talking about is one of the parallel lines, like this one right here, then it's going to be angle 5. So we've got two options here. It could be angle 7 or angle 5. And now finally here, the leaning tower of Pisa leans at a 60-degree angle with the ground. Okay, so we know that this is 60 degrees here. How many degrees would it have to move in order to make the tower perpendicular with the ground? Oh, okay. Well, 60 degrees with the ground here. Okay, so perpendicular, remember, is 90 degrees. So what I'm looking for here is I'm looking for the complementary angle to 60 degrees. So I'm looking for the complement. So it'll be 90 degrees minus 60 degrees. I can do that on my calculator, or you might be able to recognize it. You might be getting used to these pairs of angles already, but you're going to get 30 degrees. The leaning tower would have to be kind of rotated there or pivoted about 30 degrees for that to make for that to be perpendicular with the ground.